Hello, everybody. So the quiz solutions for most of the quiz are already on Desmos. You've seen, I've responded to almost every slide. If I said great, correct, yes, or something simple like that, you just got it right and you showed enough work. Otherwise, I tried to correct you where you went wrong. Uh, all except for slide 6 and slide 8, I did not look at because I just wanted to. The first several students I looked at, there wasn't a lot of explanation, or it seemed like there wasn't too much good understanding of what was going on. So we're going to look at slide 6 and slide 8 together. Slide 6 was asking, is cosine of theta equal to the cosine of negative theta? Well, I have no idea, so let's just investigate. Let's say theta is 82 degrees, so negative theta would be negative 82 degrees, and let's think about their cosine. Well, 82 degrees is something like that, and negative 82 degrees, let's do it blue, negative 82 degrees is something like that. Now look at those two cosines. I don't know what it is, but it seems to me that they're the same. What about 252 degrees? Well, here's 90, 180, 252, something like that. That's 252. For negative 252, you would go negative 90, negative 180, something like that. And again, the cosine is negative. I don't know what it is. It's not negative 1, but it is negative, and it looks like they're the same. What about radians? Where in the cusp word is 19 pi over 10? Well, that's pi, right? In other words, it's 10 pi over 10. And if I go all the way around, that would be 20 pi over 10. But I don't want to go all the way around. I just want to go to 19 pi over 10. So that's 1 pi over 10 away. So it's around there. It's definitely in the fourth quadrant. And the cosine is definitely positive because I had to go to the right to get there. If I rotate the other way, 19 pi over 10, I hope you can see that the cosines would be the same. The truth is, cosine of theta equals cosine of negative theta. But 3 and negative 3, I want to do this. Notice there's no degree. We're not talking about 3 degrees. I'm talking about 3 radians. And you know that that is how many radians? That's pi radians. Pi is about 3.14. So 3 radians has got to be just a little bit less than pi radians. And if I go negative 3 radians, it's about there. And these cosines are both negative, and they look like they are the same. So the solution is that cosine of theta does equal the cosine of negative theta. And whenever that happens, that means we've got an even function from semester 1. If you replace the domain with its opposite and you get the same results, that's an even function. And it's symmetrical on the y-axis. What about sine? Ooh, I don't know. Let's see. 192. So here's 180. 192 is about there. And I don't know what the sine is, but it's negative because sine is y. And you're going to go down. Negative 192 is there. Notice they have the same cosine, but I'm talking about sine now. I don't know what that sine value is, but it's positive. And this sine value is negative. But can you reason through that whatever those two y values are, however far you went up to get that y value, you went the same distance down to get the other y value? That is true because of the symmetry of the circle. Let's see if it works for all angles. 25 degrees is not too far, but negative 25 degrees is also not too far, but in the opposite direction. They have the same cosine, they have the same x value, but we're talking about sine. This sine value is some positive number, this sine value is some negative, but I went up as far as I went down. So what's my conclusion? Okay, 6 pi over 5. Well, there's 5 pi over 5. So 6 pi over 5 is just 1 pi over 5 more. It's about there. Negative 6 pi over 5 is about there. Again, there's sign values. However far I went up to get one, I went down to get the other. And then 1 and negative 1. Remember, that's pi radians. So that must mean that that's 3 radians, about. Because a little bit more gives you pi radians. So 3 radians is about there. If I divide that up into thirds, so let's say that looks like 3. So each radian is about that long. So 1 radian is about there, about yonder. In fact, 1 radian is about 57 degrees, about. And if I go down 1 radian, their sign values, the y's, I've got 1 positive and 1 negative. So what's the truth about sign? They're not equal to each other. I haven't had one situation where they're even close to being equal to each other, but they are opposites. They are opposites. If you've got the sine of an angle, the sine of 805 degrees, let's say it equals, I got my calculator right here. The sine of 805 is about 0.996. That means the sine of negative 805, without even touching my calculator, is negative 0.996. Opposite domains will give you opposite ranges in this case. And when that happens, it's odd. And then some people are still struggling with the unit circle, and I get that. Let's just talk about this very quickly. Where do all these weird numbers come from? Well, imagine a right triangle, 45, 45, 90. Now, since it's a 45, 45, 90, I want to label one leg of something. I'll just call it A. That means this also has to be A, doesn't it? And since 3,000 years ago, not that long ago, but a while ago, this guy named Pythagoras is credited with noticing that if you have a right triangle, you could do leg squared plus leg squared, and that will equal the hypotenuse squared. So that's what I'm going to do here to find this. So I do a squared plus a squared equals hypotenuse squared. These two are like terms, so that's 2a squared. I got to square root both sides, so I get the square root of 2a squared. The square root of a squared is just a, so it's a times rad 2. So a rad 2 is the hypotenuse. Now, so what? Well, I've got a right triangle, and I can find the sine of 45, which is opposite over hypotenuse, a over a rad 2. A over a rad 2, the a's cancel out. It's 1 over rad 2. Multiply both sides by rad 2, and you get rad 2 over 2. Same thing with cosine. The cosine of 45 is adjacent over hypotenuse. It's the same ratio. Tangent of 45 is opposite over adjacent. A divided by A is 1. And you reciprocate those for the reciprocals, cosecant, secant, and cotangent. What about 30, 60, 90? Well, I drew a triangle, 30, 60, 90. I have no idea what these sides are. No idea. So I'll just call this one A. Why not? Now what am I going to do? Unlike 45, 45, 90, where I could find 2 legs pretty quickly, that's not the case here. So what am I going to do? Something very clever. I did not think of this. Someone else did. You could just redraw this triangle. And what does that give you? That gives you a equilateral triangle, 60, 60, 60. And if you have an equilateral triangle, then this little side, if that's A, then this little side is A. That means the whole thing is 2A. So I'm just going to go back up here and label this 2A. So this little guy's A, the hypotenuse is A, and now I can use Pythagorean theorem again, because leg squared, let me get rid of the distractors here. Hold on. Leg squared plus leg squared equals the hypotenuse squared. A squared plus the other leg squared equals 2a squared. Well, 2a squared is 4a squared. Subtract a squared on both sides. These two are like terms. You have 3a squared. Square root both sides. You get the square root of 3a squared. The square root of a squared is a. And so that leg is a rad 3. Now, what's the cosine? Oh, sorry. What's the sine of 60? Sine of 60 is opposite over hypotenuse. So the sine of 60 would be a rad 3 over 2a. And where's my fraction bar? The a's would cancel out, leaving you with rad 3 over 2. In fact, here they all are. You've got 30, 60, 90, a rad 3, 2a. You can find all 6 trig functions of 60 degrees, which is pi over 3. So the cosine of 60 degrees is adjacent over hypotenuse, a over 2a, which is just 1 over 2. The tangent of 60 degrees is opposite over adjacent. So a rad 3 over a, the a's cancel out, it's just rad 3, and then 30. So I hope that helps. Also realize that the co and cosine means complement, as in two angles that add up to 90. So 30 and 60 are complements. So when you've got the sine, when you know the sine of 60, if the sine of 60 is rad 3 over 2, then the cosine of 30 will be rad 3 over 2, because 30 plus 60 equals 90.